we begin, guys. How many of you are working and how many of you are freshers? Guys on the Zoom, please. As if everyone is working?
No, sir. Fresher.
No. Freshers. Okay. Okay. So what it takes? Here, okay. So this is first day. Let me adjust it a bit. Okay. So what it takes to execute a program or a service? Anyone has an idea? क्या चाहिए होता है for a program to execute? Compiler. Okay. Before that, flowchart. Before that, algorithm. Yes, of course, you can do that, but that will be in your head, right? And your mind. I am talking about the physical execution of the program. Infrastructure. What kind of infrastructure we are talking about? That is too long shot actually. Just come. Let's say I ask you to do something. I ask you to write all multiples of 2 in a line. What do you do basically? You write what? A program, right? And then execute. Where do you execute? Console or editor. Console or editor. Where is that console or editor is hosted? On your machine. So now there are multiple ways you can write a program. You can write on paper and execute just to see that you have written it properly. But does that make sense? No, because we actually want to use computers for long computations or difficult computations or very big computations, right? For that purpose, what you require is a computer. So what happens when you write a program? What you do is you save it as a maybe a file, then you give it to a compiler, correct? Compiler compiles it, prepares an executable, which is loaded into this computer, which runs this particular program. Now look at this picture one more time and tell me, where do you store this information? Where? Yeah, that's it's okay, man. Huh? No, on machine, right? So this is where you store the information. For example, on your hard disk. Once you have hard disk, what happens? This is just a program, right? You want to compile it and then run it. Where does this execution happens in your computer? Where does it happen? You need to load it into computer. What does it mean? It means you need to get all these bits, right? Because these are bits and bytes into something called as RAM, which is memory, correct? And then it is given to some kind of a processor for to execute. Now, once you execute this program, you want to refer it maybe afterwards, right? For example, you are writing some simple program or some projects where maybe sometimes we do this kind of projects, right, in our colleges, library management systems, shop management systems, and all those things. What we do here, we maintain the name, age, and all this kind of information. Where do we keep this information in these cases? We want to store it somewhere, right? And that storage is basically in the form of mostly databases. Ultimately, those are stored as a files only on your hard disk. That means whatever you do in computers, you require basically two fundamental pieces. There are actually three when we are talking about the call-out computing. But let's begin with the two fundamentals. What? You need a storage and you need a compute power. Without this, nothing works. Correct? So this is your computer. You write the program. Once you write the program, you load it into the RAM, ask the CPU to execute, it works, and then you're happy. Right? Otherwise, you debug and then you try to correct the program. That is the basic thing. Okay. Now, in cloud computing, third angle comes into the picture that we will see afterwards. So basically, what I want to tell you that, okay, for anything to work, as he said, you need to have some kind of a infrastructure. Okay, that infrastructure will be provided to you. For example, for our batch, when we are learning AWS, what is the infrastructure that is available to us? This room is a infrastructure. This bench is an infrastructure because now you are sitting here comfortably. Okay, this AC, TV, everything is a infrastructure. Correct? So what we require first is infrastructure. So infrastructure is the basic where you keep all the things together. Okay. So the very first thing, why I'm covering this thing? Because this is important when you want to understand what is cloud computing. Okay. Cloud computing is nothing different than our daily computing, whatever we do on laptop. But there is a magnitude of difference. That magnitude of difference we want to understand it. Okay. So the very first thing is what? Infra. After that, now you have infrastructure, everything, right? As I said, you need now, let's say, this computer to communicate with this computer. Nowadays, you do it everywhere. Earlier, 20 years back, 25 years back, it was not the case. There would be some different kind of things. But nowadays, we take it granted that the communication or network between two things is there. For example, take the example of this particular thing, right? This is mobile. Is it a simple mobile? No, it is a smartphone. Why it is a smartphone? Because now we are able to consume the services from the far end. We don't know, right? For example, you go to Amazon.com. You might have some kind of Amazon app here, right? You open, you do the shopping. For example, you go to Instagram, you take photos and upload it, and then your friends can see it. How is it even possible? It is possible because these two computing machines are now connected by internet. Okay. So here, if you see the infrastructure is this kind of physical environment where the computing can happen comfortably. Now, basic here is for these things to work together, you need network, storage, and all other things. Okay. How many of you have seen some kind of a big rack, server rooms? How many of you have visited? Movies में तो देखा होगा, मैट्रिक्स देखा है किसी ने? Any other movies? वहाँ पे ऐसे blink होता रहता है, right? What are those called? Those are server rooms. You have a lot of servers connected by wires together. Nothing more than that. So the networking, storage, that kind of. In the networking or whatever you call, this is basically called together as data center or something like that, hosting facilities, right? So here, if you go and see in those pictures, you will see big racks, right, on which a lot of computers or machines are connected. So what are those? Physical servers. Those are the physical servers, actual machines, actual hardware that is required for this computation. So look at this stack, and how the things are stacked up. After that, what happens is on the servers, when you open your computers, right? What do you see? Just open a computer. What do you see? The very first thing on your machine. Password is asked for the password, but who asked for the password? System, right? What system? operating system, right? That means there has to be some kind of a operating system which is running on this physical server. Unless it is there, you cannot do anything. Then this was the actual picture, okay? Some time back, like 20 years back. But now there is something else here. On one machine, you can, on one physical machine, server machine, you can have hundreds of other machines running. What it is called? Virtual machines. So 20 years back, this was true, 25 years. And I still remember, like in 2003 or 4, I first time heard about VMware. Okay, before that, what used to happen, there was some utility called Norton Ghost. You will just take a clone of your full machine. If you want to take another machine and make it look like the earlier one, you just clone it with bits and pieces, just like that. But VMware and the virtualization changed the whole picture. So now you will see this is not a OS anymore. This is a virtualization layer. On top of, now you can see operating systems. Okay, one machine now can have multiple virtual machines running here. For example, some of these would be running Linux, some of is another Ubuntu or something like that. Those kind of things. Right? After that, operating system done. What else? This is your application. I will start now from this side. Application. Guys on the Zoom, can you see it properly?
No, sir.
No, sir.
No, sir.
Now?
Yes, it's visible.
Yes, sir. Yes.
Yes, sir.
So this is application that we are talking. So what are we talk here is at this top layer. For example, how many of you use Gmail? Everyone uses. So that is what? Application. Now, Gmail needs something or Amazon needs something for it to work. You want to send a mail, let's say, to your friend. What do you require? Come on, guys. Just be fun. That's it. There is no wrong and no correct thing. This is the beauty of this field is, or this industry is, there is no black and white. Okay, you need to understand one thing very clearly. There are only gray areas here. Okay, you will see the trade-offs. That okay, I want to do this thing, and this is the bad thing. Whether I make it happen or not. That's the only thing. Okay, no correct answers or incorrect answers, unless you're talking about the binary search. Okay. What do you require? Data. Data in the form of, for example, I want to send a mail. I would require the email ID of the person to whom I want to send the mail. I want to add some attachment to it. I want to add my photo, my mail, my something else. That is a what is called data, right? Now here something else happened sometime back. Okay. Where were we? something new into picture now. After virtualization, something happened. Containers came into picture. Containers. Have you heard of containers? Docker containers. Have you? Right? Yeah, you should be hearing it more and more once you get into industry, okay? Because everything now runs on this containers, nothing else. Why? Because the virtualization is a very heavy layer. Containers is a very lightweight layer. For example, on one operating system, you can have multiple containers running. Of course, because now it is for the same operating system, you cannot have the different operating systems. Okay, that's so. If you say this is the thing that you will be saying for one application to run properly, this is called as infrastructure stack. If you understand this thing clearly, you will understand cloud computing easy. Okay, cloud computing is not a magic, but it will do the magic for you guys. Okay, or even for me. So the name of this course, I will say, I like this name actually. Always like this name. This is AWS for fun and profits. Okay, so why is fun and profit? What is the meaning of fun and profits, by the way? Fun to learn because you are interested into this thing. You have come and joined this particular thing, this course, because you are interested in learning something. You want to advance your careers in this particular field, right? This is fun part. You want to advance your career in this field. That is the profit part. So you are going to get both the things. And that's the beauty of this particular field actually, computers. You love it and then you make money out of it. Okay, that's why AWS for fun and profits. This is a beginner level of course. We're not going very deep in this course, but you will understand each and everything about the cloud computing. Okay, so in this course, what is going to happen? We just learn infrastructure stack. It is a basic that is important for you to understand why the things work the way they work, why we call few things the way we call them, and anything like that. Okay. Then we'll go for the definition, basic definition of cloud computing, why it is called cloud computing, and everything. And during this particular course that will run across multiple weeks now, you will learn to do some live project. Okay. So understanding is that once you are done with this particular course, you would have completed one live project. And I like one particular project very much, which is, I believe, you may also like. I want you to write one Instagram code. Everyone loves Insta, right? So you can write your own Instagram, post it on AWS if you do it properly, and get benefited. So it will give you a sense of learning. What you have learned, you are going to actually implement it. So there is nothing different. So you'll understand that, okay, you will be writing some code, which you do anyway. This is nothing special for cloud computing. But what is different is the deployment. How will you deploy and use it? You understand what is deployment? Right? Okay. So what I want from you guys, first thing is I want you to have some dedicated time for learning. Okay. This is going to be very dense course. That means, and fortunately for you guys, there is like a 5-day gap because this is weekend batch. So you have 5 days in between where you are supposed to read a lot of things. Come prepared next week. Whatever the assignments are given, you are supposed to complete those things. Okay. Then AWS account, if that is possible, but that is a dangerous thing. So just hold on. Okay. Always say AWS account is an atom bomb. Okay. That is given to kids like us. So we need to handle it very carefully because you need to pay for it. Okay. That's why. If you're not able to get an AWS account, there are other alternative sources. For example, there is a site called AWS Educate. right? You can go and subscribe to this site. It will give you some kind of a feeling of console, AWS console, actual console. It will not be real thing, but it will just try to simulate it for you. Not each and everything, by the way. If you are a student, you can always, there are student programs. You can go and search for the AWS student program. You can search for that. Okay. If you are in colleges, you might have something called as student chapters, AWS student chapters. Get associated with those chapters as well. If you're in colleges or everywhere, you don't have those, try to start them. Okay. And obviously, I would require you to have some kind of a laptop with you so that you can practice. I believe that is the thing. So far, so good. So what is AWS or cloud computing? So AWS is one of the cloud providers. Do you know other cloud providers? Azure, Google, GCP, right? All those kind of things. Oracle, of course, Oracle. There are many nowadays, but the thing is, cloud computing, as we know today, started with AWS. But you don't misunderstand that cloud computing started with AWS. It is not the case. In fact, in 1970s, someone actually defined the characteristics. What is the cloud computing? At that time, they would be calling it as time sharing concept. Okay. And you would be amazed to understand one thing, that the term cloud computing is coined by one of the Indian guy in US. Okay. He coined, I believe, Chelappa or someone who coined the term cloud computing. It was used very first time like that by an Indian guy. So the cloud computing, you can say that invented by, or at least named by some Indians. Okay. Now, cloud computing has multiple definitions. You ask anyone, they will tell you different things about cloud computing. What they will say, okay, there is some server, I don't see, I can connect and get the things done from it. That is cloud computing, right? That it can be one of the definitions. Another guy will say something else, because I don't see the computer, I call this cloud computing, but that is not the case. So cloud computing, something, if you want to call it as a cloud computing, it needs to have some kind of a characteristics. The basic characteristics are these five. Self-service on demand. So these characteristics, I'm taking it from NIST. So NIST formally defined this thing so that people should not have any confusion now what is to be called as a cloud computing. And they define these five characteristics. Can you say it? First one is self-service on demand. Self-service. What is the self-service? Give me one example. खुद से करना है, right? One example, maybe that would help.
Resolve itself.
Huh?
Resolve its own. Resolve itself.
Yeah, that is clear. But example, I'm looking for one example. Okay. Do you go to PVF? Not many times, right? So you have these tickets and everything, and then maybe you just go there and scan it somewhere, take out the print, then show it to the gatekeeper. Nowadays, you don't have to, but earlier that was the case, right? Or some other places, you see big vending machine, you put some coins, you get a Coke, right? So that is what a self-service. Do you need any man here? No, you can just go and say that I want this thing. Put it, no middleman, nothing. So that is called self-service. Anyone, whenever you like it, whenever you want to have some cool, you just go, vending machine, get a Coke. Done. So that is the same thing here. For example, if I want to do some kind of a computation, let's say what I do is I request one machine to be created and I can use it. Once I'm done, I can delete this machine. That is self-service on demand. No middleman. Whenever you like, do it, use it. Broad network access. Now the thing is, this is somewhere I don't see where this machine is hosted. I cannot even go and touch it. Right? This is my laptop. I can go and touch it. But can you see or do anything? Touch this machine physically? No, this is cloud. That's why it's called cloud computing, right? So basically, if you want to touch it somewhere, you need to have some kind of a network access to it, right? So something you can connect from here on demand. You whenever you require this machine, you create, use it, and discard this machine. So that is the term which is broad network access from anywhere. It's not something that you can touch it from your laptop only. If it can be done from this mobile phone, it can be done from server machines, anything. Only thing is, this should be some kind of a device which understands this network protocol. Yes. Resource pooling. What is a pooling? What do you mean by pooling? How many of you love swimming or seen a swimming pool? Obviously, right? Have you seen a swimming pool? Right? Summer में हम लोग जाते हैं. What happens? You feel like you're sweating and you just want to get into swimming pool, but then you see what 100 people already in the swimming pool. So what you are doing is basically you are sharing this swimming pool with other guys. You are sharing that particular swimming pool. That is what is resource pooling. So this guy who is providing you the service is not doing it for you only. He's doing it for thousands, millions of other customers. So that is the resource pooling, right? Understood? The someone still ask me. Okay? Don't not. Okay? Just be clear, okay? We want to learn the things, okay? This is something very important. If you understand now, then you will understand all the things. There is no magic. But one thing, guys, in industry, if you want to grow and survive, is you should be able to speak. Speak without fear. Okay? As I said, there are no blacks and whites. Always gray. Everyone has an opinion and your opinion counts. Okay? So don't be like this. Guys on the Zoom, please do ask me if you don't understand the thing.
Yes, sir.
Okay?
Yes, sir.
The next thing is rapid elasticity. Now, you are standing in front of your vending machine. You are having Coke, and suddenly 5 of your friends come. What do? You share your Coke. You get more. That is rapid elasticity. Elasticity. Okay, it is elastic. That means if you are stretching it, it will also go back to its original position. That means whenever you are done with your requirements, you can actually return the resources back. You can scale down, rapidly scale up and rapidly scale down. That is what the meaning of rapid elasticity. Another example, for example, you go to restaurants, right? You go to restaurants. Then there are some tables. What is the standard size of tables? Most of the time, 2, 4, 4 mostly. What happens like when 8 people come? What do those guys do? They join the tables, right? That's how you are served now. But let's say 4 of your friends go now because they want to watch movie. You are now spending some chill time. What happens? You separate the tables. That is the rapid elasticity. That is what happens in cloud as well. Whenever you want resources, you get it. When you don't want, it goes down. This is measured service. What is measurement? You see, he is serving you, right? That means he needs to count how many spokes he has served. Then you need to pay for that. So that is the major service. So this is the diagram that I prepared for you and some examples or something you can go for. And this is very important characteristic by the way. This is very distinguishing characteristic. For example, pay as you go. जितना यूज किया है उतना ही लगेगा. It is not something कि हाँ मैंने कुछ extra pay करना पड़ेगा. Whatever I'm using, I need to do this. But there is a problem with this whole thing as well. Okay, if you go back to resource pooling, for example, what happens is now the resource pooling is this guy wants to give some kind of services, right? So obviously he needs to standardize it. Standardize it. For example, whenever you are asking for a machine, your requirement might be different. For example, you might require a machine which is having like, let's say, 8 GB of RAM. Okay. He is another guy who is very interested in gaming. Who is interested in gaming? So you need machines with what? GPUs, lot of memories. That means your requirement is different. But can this guy serve you? Because someone else may have different requirements. So what happens is they actually standardize. They standardize, okay, there will be machines with 8 GB RAM and maybe 8 virtual CPUs. Tomorrow when you come, please read about the virtual CPUs. Okay, very interesting. Another offering could be that it will be 16 GB of RAM and let's say 32 virtual CPU, like this. So this is how the provider will standardize the thing. And तुमको उसी इसमें मिलेगा. For example, you go for a Coke, you will have a 300 ml, not 300. What is this? 100 ml or something, then 300 ml, and then big bottle. You cannot have like 2.5 liters of Coke, right? That's a standardization. That is what happens in the resource pooling because he wants to give you those kind of services.
Sir.
Yes.
Sir, please share the PPT.
Oh, I did not. Okay, give me a moment. Thanks. You ask. Sometimes I tend to forget. Okay, please do ask. Can you see it now?
Yes, sir.
Okay. Okay. Speak up, guys. Don't be late. Now, something about AWS. So we learn about cloud computing in general. Now we are going into the specifics. So AWS cloud history, we are going to start. Very interesting history. Where do you think AWS wrote his first service? Where? Location. Can you guess? Yeah, it used in Amazon, but when it coded actually for the external customers, it coded it in some other place. Yes, Amazon did it, of course, but I'm asking for geographical locations. What is your guess? No, don't murmur, okay, just speak up. No. So where is the company Amazon from? Originally? US. So what is your guess now? No. No. that's a good thing actually. Okay. They actually wrote this service in South Africa. Okay. In South Africa, they set up a very small team because the guy who was leading this whole project, he wanted to spend some time in his home country with his family. And the Amazon said, okay, let's do it your way. And that's how they actually coded the very first service into AWS in South Africa. Okay. I use something now. I don't know whether you paid attention to me or not. I use a term service. Did you pay attention? Yes, right? So this is the term you are going to hear often, and very often, because now the AWS is giving you the services. It tells you the notion. The notion is that they are serving you. You are asking for something, you are getting served. Okay? That means there has to be some kind of an interaction, right? You are the client, they are the servers. So normally when you do this kind of a computing, what it is called? Client server architecture. Okay. And when you want to do this thing, this interaction happens over, as we saw, network, right? But then you need to understand कौन सा service call करना है मुझे, right? And what you want it to do. That means there has to be some kind of a specification. For example, I want a machine, right? So where do you go? You go and ask for a compute service for a machine. But how do you even tell that? You need to have some kind of a standard place where you can go and ask. For example, when you go to when you want to eat a hamburger or burgers for sake of it, where do you go? McDonald's. So basically what you do, you take out your phone, go to maps, find the nearest McDonald's, go to McDonald's and ask for what? You ask for the burger, you don't ask for the services. Okay. Yeah. So basically what is happening here is you need to find that place where you might get served. You need to ask them, okay, I want a veg Maharaja burger or something, or another whatever you like it with all the ingredients, and then it will be served. That means you need to know where to ask the service. That means this is called as a, you need to understand. We're talking about technical terms, okay? Endpoint. This is serving you, which is called as a, it is called as a API, okay? Application Programming Interface. Understood? This is API. API is a standard signature that you know, I know. This service has published some standard signature that you know, you can use that. One simple example is, have you written any C program where you compare the strings? No? Not anyone? Any other language program where you compare the strings? Yeah, it's okay. Java, right? What function you call? That's a C function, but I will take it. str CMP, right? So this is what you do. You give string 1, string 2, it returns you something. What is this? Comparison. Yeah, that is comparison thing happening, but this is called as an API. You know, the system knows, system actually understands. Yeah, you will be sending me 2 strings. I will compare it and return you the result as a integer value 0 when it is true, all that kind of. So this is agreement. This is what you mean by API. Okay. Only thing is this API, if you see here in this program, this is implemented by C runtime. Instead, this will be implemented by the cloud service providers. That's the only. Okay. Another only difference would be this is running in one process on one machine, one computer, but this is happening across the network. So you'll be writing something, it will be coded, sent over the wire, reach here, it will again decode and then serve. Okay. So basically, Amazon started in late 90s, okay, around 1997, it went public and it had very huge impact on American lifestyle. Until that, everyone was doing the window shopping or the physical store shopping and everything. But Amazon changed everything. So what happens in US? In US, there are something called Black Fridays. Yeah, so those sales are there. So very big sales that happens over the period of like 2 days, 48 hours. And people actually go and do a lot of shopping. Before Amazon, what used to happen? People would stand in the lines and then they will be waiting for the store to open and then they will start rushing to the store and buy the things. Okay. But Amazon changed everything. That means they needed some infrastructure which was huge. But the problem with this huge thing was Black Fridays would happen only once in a year. So they would be running some kind of other events as well. After around 2000 or 1999, they launched Prime, Amazon Prime. Then they started regular sales as well. But what would happen is, you see, there would be sudden spike and then small, no usage of the services. So someone from the AWS, from Amazon basically said, we have this huge capacity of computing and all the infrastructure, but we are not utilizing it. Why shouldn't we sell it to other people? Interesting thing about Amazon is when they started writing the internal things, they actually wrote them as services. Services. Even internally, they wrote the things as a services. So whenever the different teams started different things, what happened? They actually could communicate internally as if they are serving each other. Okay. So this services architecture enable them to get into the bigger business. Okay. Because now what they had to do is instead of just pointing this service, they had to point it to the outward. Okay. So this is how it started. In 2002, it was launched internally and everything. And then in 2004, they started with something called as a SQS, queuing service. We'll cover this thing. Don't worry about all this. And in 2006, what happened is they started with one of the most important service, that is EC2, S3 and SQS. So these two things we will hear very often. EC2, you would have seen it all the time. EC2. Okay. In 2007, they launched in Europe. So they were starting expanding. And here, because of this whole thing, you will see there is a very interesting thing in AWS architecture, how the things work. So around the same time, I heard about AWS. Around, I believe, 2007-8 time, I first time heard something called as AWS or cloud computing, and then we started our own research. What we can do about it. I was in CA at that time, but these guys were way ahead of us. Okay, the Dropbox, Airbnb, and everything were way better ahead of us. So they started using these services. You will ask me why. Why? Before I answer, can you tell me why do you think they started using AWS? Cost saving. Right, cost saving.
Have to use their own infrastructure.
You don't have to use an infrastructure. For example, if I ask you to write a Netflix like a service today, okay, I am only one person, or I have, let's say, another friend who is joining my startup. Let's assume AWS is not there, no cloud provider there. What I have to do in that case? What do you think? I need to write some code. Correct? This code needs to be compiled and then posted somewhere. Correct? Servers. Then if my service picks up, I will add another server, another server, another server. The only problem is most of the people are using it as for trial. They are not paying me. My service is scaling, but I'm not getting paid. I'm buying the server. That means what I need to do, you see here, I need infrastructure. I need to rent some place to keep it because these are big servers. They're going to need some kind of a cooling, right? That means I need to spend some amount on cooling as well. This service needs to be interconnected. That means I need to have one guy who knows the networking properly. You can sit here and do the networking for me, correct? And all these things. So this will require me to put a lot of money upfront, even when I'm not getting any revenue. Would I do that? I'm just a normal software engineer. I don't have that much money. I won't do that. So you will not see a Netflix. You will not see Dropbox. You will not see Airbnb. What AWS enable these guys to do is they don't have to think about this whole thing at all. What they need to think is what they require here upwards. Right? I don't care. I just give me one machine. If I require another machine, I'm just spawn it, right? That's it. So you see what happened? The first principle, the first characteristics, I could launch a new virtual machine anytime the service picked. Third thing, rapid elasticity. Wherever it is increasing, I'm adding, but wherever the load is decreasing, what I'm doing is I'm just removing. When I remove major service, I'm not paying for it. I'm paying only when I'm using 3 machines. When I
We are right now.
Oh. So can we talk to her? Because उसने दिया है मुझे.
Is it here?
हाँ सिंगा. Admin सिंगा. ठीक है. Okay. So all these characteristics you can now start relating to. So this is how the AWS came into being. This is how it started dominating our lives. And you will see AWS is used not only by Netflix, Airbnb, or anyone, but it is nowadays used by almost everyone. For example, me, I'm hosting my services on AWS. I'm not renting any server, physical server or anything. I can do it because it can do magic. I was working with Dhruva earlier. Dhruva is in SaaS backup and space basically. Recovery spaces. All our infrastructure was hosted in AWS. What are the backups we take? We keep it into S3 buckets. What are the computation needs to be done for that? That would be done to the virtual machines in like this. So now, coming back to the thing where I said in 2007, AWS started expanding to different regions. So it started with US, then it expanded into Europe, and then it get expanded. Why this expansion is required? We cover that point. Okay. Now the thing is, when you say expansion, what really happens? This is something you need to understand. AWS has something called as regions. Okay. US, Europe, Asia Pacific, like this. So different regions. AWS services are hosted across multiple regions. So what is actually when we say that it is a region? You know, when I started with this whole thing, actually they are going to host the whole thing here. Okay, that is going to happen in some kind of a data centers. That means they are setting some kind of a data center in this one region, another data center in this region, another data center in this region, like this. Understood? Before we go there, by the way, I just want to quickly touch on something. Service models. We saw it serves as, right? It is served through different service models. Please ask me if you don't understand or anything like that. Okay. First thing is called as AS, infrastructure as a service, right? Platform as a service, SaaS, software as a service. Okay, these are three different models. How they fit here? Let's see. So here, the thing is, we are actually calling AWS or using AWS for some kind of an abstraction that we need. In software, you always see the abstraction. For example, you have a physical hardware, which is
सर
Yeah.
सास वाला कौन सा है?
SaaS, software as a service.
Okay.
Okay. I was saying, this is your CPU, correct? Which understands only machine instructions, bits and bytes, but you actually write into some kind of assembly, on top of which you have high-level programming. Likewise, what happens here is basically abstraction. What is happening here is abstraction. You are adding one level of abstraction. For example, you write the program, you call this strcm. It has implemented this thing. This is giving you the abstraction. Similarly, we are looking at the abstraction in the infrastructure stack now when we say as, PaaS, and SaaS. So here, this is the place where the separation happens. Look at this whole stack. Now you can see that AWS owns this part, or any cloud provider would own this part. What they are doing is they are hosting the infrastructure. They are paying the rents of the buildings, coolings, and everything. They are paying the network guys. They are paying for the network cables and everything. They are paying for the physical boxes of the machines. They are actually hosting the virtualization layer. Okay, for example, Xenix, their own implementation and everything. So this is owned by AWS. Earlier, this whole stack will be owned by us on our machines, physical servers. But now, this is the separation. This is important to understand that there is a separation of the concerns. This is called as, if you go a little further, there is something called the shared responsibility model. This is called as a shared responsibility. You share the responsibility with AWS. Earlier, when the whole stack was owned by us, it will be owned by completely by us. It was our responsibility. For example, building में कोई चोर ना घुसे. So I need a guard on the building store, right? Who's paying for that? I am paying for it. But let's say you don't do that. You just go and host it in your data center. That means this data center guys will be paying for this whole infrastructure. You will be responsible only for this kind of thing. So when, for example, Facebook started, Facebook didn't have this whole stack. What they did is basically they paid to a data hosting company, data center company. So this is DC hosting. So there would be a lot of data centers in US, in San Francisco and LA side. What they would be giving you this kind of things. They would be providing you networking and infrastructure support. You were supposed to have your own physical servers and everything. Okay. So what Facebook would do is whenever they wanted to increase the, because they wanted to scale, what they would do, they will just add new physical machines into the racks, interconnect, and start expanding like that. And when earlier days of Facebook, what you would see is for each and every college, they would have a different rack basically. They will just name it like MIT, Stanford, and blah, 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 blah. But ultimately, they converge. So what I'm trying to say is, here, there is a separation of concerns. Up to this point, AWS is managing everything for us. Now, from this point of onwards, you will be using it. Okay? The operating system we are talking. For example, when you say infrastructure as a service, IaaS, right? This is the infrastructure that you do. That means you get a what? Operating system to install and move ahead. So basically, you are now getting a choice. Which operating system you want to use, how you want to use it, and likewise, where do you want to store your data and what you want to host on that particular machine. So this is decided by this service model. In this model, what you get? You get a virtual machine where you say that I want to have Linux install on this machine, or Windows install on this machine, or Mac install on this machine. You get that machine. And after that, it is no concern to AWS. You are responsible for whole thing. You patch the things or you don't patch the thing. None of the concern to AWS. Now, what happens is, we did not write about runtime. Why we're talking about the runtime now? For example, you want to run a Java program. What you require? You don't require compiler to run a program, right? You require JVM, runtime. Okay, Java virtual machine. Similarly, if you want to run a C application, you need C runtime. Likewise. So basically, runtime is the thing which is required by the program for its complete execution. Okay. Now, what happens is, this is where the platform as a service starts. AWS is taking care. Now here again, AWS. Look, AWS management is going up now. AWS is taking care of operating system installation. AWS is taking care of running the containers, what are the technologies required. What you are supposed to do is you need to write some code and provide the code to AWS so that it can execute that code. This is basically happening through different AWS services, for example, Lambda. Don't worry, we'll learn about the Lambda in detail. Okay? So this is pass. Now the thing is, here, SaaS hacks. For example, Gmail, Instagram, anything. When you start using Instagram, or does Facebook tell you that okay, you need to install this source? Does it tell you that you need to have a Java virtual machine? No, right? What it tells you, just download this app and it should be running. So what are the things are happening that is happening inside this whole stack? We don't have control. What we are doing is we are just consuming the service. So you see, when we started from our side, we are responsible for this whole stack. Okay? But when we started with infrastructure as a service, we are responsible for OS patching onward only. When we started with PaaS, only runtime onwards, and when we started SaaS, we are responsible for nothing except subscription and paying the fees. So these are called as service models. Clear? I see most of the time people get confused with this. PaaS. PaaS is little difficult to understand. But when you get an experience in this thing, you'll understand what is PaaS. Okay. Guys on Zoom, any questions? Any doubts? Anything not clear? Okay. So we said that AWS infrastructure is distributed or partitioned into multiple ways, and those ways are AWS regions. For example, some of the data centers are hosted in Europe, some of the data centers are hosted in US, some of the data centers are hosted in Asia, Pacific, and likewise. Why do you want to do that? One reason. Right? When I'm in India, my server is in US, how much time it is going to take to connect to this machine, do something, and return with a response. Obviously, it is a kind of a whole world round trip, right? So it is going to take longer time. So this is called as what? Latches. You want to minimize the latches because you want to serve your customers as quick as possible. For example, तुमने Gmail open किया and it is hanging for like 1 minute. Would you be interested in using Gmail? No, right? But if it is just like within a second, it gives you the response, you'll be interested. The same thing with the Instagram, not those places, right? Another thing, loss. For example, when you are using applications like Gmail or Instagram, you provide lot of information which is personal to you, okay? Or you are using another applications which are hosting very sensitive kind of information. In that cases, law will say that this information should not cross our geographical region. For example, if you go to Europe, they are very strict about the privacy laws. What are the information you collect about the individuals? They don't want that information go out of Europe's boundary. That means if any company wants to have access to European users, what they need to have? They need to store this information in Europe only. In that case, AWS regions in Europe can help. Okay? If you see, there are multiple regions here in Europe itself. Ireland, London, Paris, Switzerland, Frankfurt, Milan, right? So why? Because this is impacting the latency as well as the loss. You will see the same thing happening for the Asia Pacific as well. Okay, so these are the two important things for which you need to have multiple regions. Let's say in India, how many data centers we have in AWS regions we have now? We have two AWS regions in India. One is in Mumbai, another one is in Hyderabad. Okay? So as I said, what is a region? Basically, region is a cluster of data centers. Data center में ये सब होता है, ठीक है? Huge things. Let's say AWS wants to set up a data center or region in Pune. Right? What it is supposed to do? It needs to rent one building and host the whole infrastructure. Let's say they do it in Hinjwadi. Correct? Some people are using now these services, connecting to these services, but there is a flood in Hinjwadi. What would happen? Building is flooded, servers are down. Would your users be able to use your service? No, it will be down. This actually happened in 2006 during Mumbai floods. What happened is ICICI का जो बांद्रा कुर्ला में data center था, it went down. For 3 days, there were no ATMs working at all. Okay, so that is a very big disruption to the services. Do you want to have this thing to happen? What do you do in that case is, what you do is, you put one data center in Hinjawadi, and then you will set another data center in say Kharadi. Kharadi is a very far away, dry area, no flood, nothing like that. So even if this goes down, it will be able to still serve. Okay, now look at this. This is, let's say, hypothetical Pune region. it has two data centers. In AWS terms, it is called as availability zone. It is called, why it is called availability zone? AZ or availability zone. What is availability zone? What is availability basically? Even if one data center goes down, another is able to serve, is available to serve. That's why it is called as availability zone. So there would be multiple such availability zones in one region. So basically, one availability zone, you can assume that is a one data centers. One data center means thousands of such stacks in one data center. Okay, that means this is the scale of the operation. Understand this thing very clear. Okay, region, it is serving one region because why? This is also serves as a API endpoint. Whenever you call something, right, you need to basically in your request there will be a name of the region for to which you are actually calling. Okay, understand? Region, usually Harari, those are called as availability zones. These are hypothetical by the way. Okay. Inside, as I said, mostly not data actually, but same infrastructure. Yes, it will be like almost 100% they will be matching. Why? Because some of the capabilities, if it happens that some of the capabilities are only present in Hillsborough, not in Harare, some of the applications would not run, right? And we don't want that to happen. So it will be identical. That plays a big role by the way. Okay. For example, what happens is not all services are available in all regions. Okay, AWS has around 355 services at this moment. And every month, I see one more thing getting added. So this is a huge scope. But the thing is, and okay, I should mention around 29 regions across the globe that serves the AWS services. And not each and every region would have all the services. For example, US East 1. Now I'm expanding the names, okay? US East 1, US East 2. These are the two regions which would have almost every service. But if you go to UAE, it would have around 80 services. Like that. Okay? This is the how the infrastructure is hosted in AWS. You can go to this particular link and see for yourself. So already covered this part. One part I did not cover. Which one? We said most of the services are regional services. That means they will be served on one region from that endpoint. But there are certain services which are global services. That means the endpoint to serve it is global. It's not region specific. I don't know whether you are following this up. How many of you don't follow this? You just have to raise like this. Everyone follows. That's amazing. All right. So we'll go back to McDonald's. What do? You search, you go there, you have this particular address, right? For example, यहाँ पे एक McDonald's है नीचे. So you got that address. So basically, what is happening is you are actually connecting to that endpoint and asking for the services. Correct? Now let's say you go to some other place. I don't know this area very well, but let's say you go to Chinchwad side, right? And you want to eat a burger. What you will do? Again, take out. You will find the address and you will go there and page the thing. Proper. So this is called as an endpoint. So you have some URL. For example, you have something like this, gmail.com. Do you know where it is hosted or something? No, I don't know. Right? But internally, some of the servers will be in Pune, some of the servers will be in Mumbai or something. So it will be actually serving to some regional endpoints internally. But instead here in AWS, guess what happens is it needs to be in one particular region. Okay. But let's say you don't find anything, you are at home, you're just enjoying, right? And then you want to have burger. What do? Order online. So basically you go to either Zomato or you go to Swiggy, or maybe you can directly can use that app, McDonald's app, and order it. This is something. Do you really care from where it is coming? This is global. So just connecting to their global service, and they are deciding from which place it is going to be served. So that is the difference. Some services are global, some services are regional. Why services are regional? You raise very good point actually. You said, are the capabilities same in both the data centers? Yes, absolutely. But now this is applicable to the region. But let's say now you are talking about a different region altogether. Right? This is region, let's say Mumbai region. So it is possible that some of the hardware that is in Mumbai region does not match to the Pune region. Let's say Pune region is a very new region. So obviously, when you start any business, do you start like a full swing? No, you don't do that. You actually start very small and then you expand the things. The same way here, the hardware is expanded. Advanced hardware might be available in Mumbai region, but will not be available in Pune region. That means some of the services which require those hardwares, if it is not present in Pune side or right or Mumbai side, so those services will not be available in those regions. For example, let's say there is service something called as a storage service. Let's take an example of a storage. When you do the storage, what you require? You require no, you don't require database for storage. Storage, bare minimum storage. Yeah, that is there. Another thing is basically you need hard disk, right? Different types of hard disk. Some hard disk has like the 10,000 RPMs and all those kind of things. Those are mechanical hard disks. Some would be another hard disk, SSDs, right? SSDs basically, those kind of things, right? But SSDs are expensive. So here there will be very much few SSDs available. In this region, there will be too many SSDs available. That means this region can give a storage service which is very fast compared to this region. And then AWS will say that, okay, there are two types of services in storage. One is very fast, another is a little bit slow. It will not tell you why, but the reason is that the hardware here is not capable of serving those fast requests. Okay, fast access. So this is how the things work. Basically. You need to understand, even if it is a cloud computing, there is a hardware involved. And that because of that, the way you see the services or get the services will differ across the regions. Okay. So again, coming back to this availability zone. Anyone has question? Doubts? Is it not very hot? No? Guys, any question? Able to understand?
Yes, sir.
Nice. Okay. So let's go in a little bit more little about the availability zones. So basically, as I said, in one particular region, there will be multiple data centers so that even if some disaster happen, you should be get served. And based on the popularity of that region, there will be multiple such data centers, cluster of data centers. For example, if you go to one of the most popular and most earliest one region, that is US East one, it has around 6 availability zones. Okay, but Mumbai region would have 3 availability zones, and you will see that 3 is the number that is getting repeated almost all the time in AWS infrastructure. So each region would have at least 3 availability zones. Why? Because if there are only 2 availability zones, the probability would be 50-50. If it is 3, the probability comes down to 33, and likewise. Okay, that means this is a kind of a distributed computing. Okay, this is distributed computing. Cloud computing is a form of distributed computing. In distributed computing, you would have to have some kind of a redundancy to serve the customers all the time. Okay, that is one of the basic tenets. So now you will see that each availability zone would be numbered as A, B, C, D, E, F. Likewise, okay, doesn't have any specific name. Okay, as I said, they are separate from each other so that even if something happens, bad happens, they are isolated. Now, one of the important things is that these data centers themselves are connected. So AWS has its own private network to which they connect with each other. It happens so that these applications now can communicate with each other very fast because the latency is very small because the bandwidth is huge. So basic pattern, you will see that the applications are deployed in one AWS region. When it is deployed in multiple availability zones. So some application, you will see the one binary here deployed, the same binary getting deployed here. And then, if required, they may communicate to each other as well. Okay, why? We'll cover that. Okay. Want to have some break? Looks like. So guys, we are taking a break, short break of maybe 5 minutes or something. Okay, and come back because after 5 minutes I will start.